Hello students, I am Adil from eduinput.com. In this lecture, we are going to discuss about Sp2 hybridization. In the previous one, the link is given in the description. We discussed general form of hybridization, where we discussed almost 6 types of hybridization. But that was our introductory lecture. In this lecture, we are going to start a very detailed discussion on different types of hybridization. So in today's lecture, we are gonna go with this Sp2 hybridization. What is a Sp2 hybridization? It is basically a process of mixing one s orbital and two p orbitals in an atom to form three sp3 hybrid orbitals. And guess what? All these hybrid orbitals are going to be equivalent in energy. So we see that one s orbital and two p orbitals. These participate in formation of three sp2 hybridized orbitals. It is also known trigonal hybridization because the resultant geometry of molecule is somehow trigonal hybridization. So in this case, it is a general example where we can see one s orbital having circular shape and these two p orbitals, lobe-like structure, they just combined to give these sp2 hybridized orbitals. And remember, the geometry of molecule is going to be trigonal planar. So let us explain this hybridization with the help of some examples. So the first example we are going to take is boron trifluoride. So we know that there are two types of atom, boron and fluorine. Basically, with the help of hybridization, we try to explain the geometry of molecules. This is a very important property of hybridization. So first of all, we are going to start with the electronic configuration of boron atom having 6 electrons. This is the ground state electronic configuration of boron atom, and this is the excited state where we can see that one electron has been shifted to the vacant orbital. This is p3 orbital. So this is the excited state electronic configuration of boron atom. So now what we see, this is s orbital electron and these two electrons are in p orbitals. So these three will combine to form three hybridized orbitals. Now we can see these three are sp2 hybrid orbitals. Okay. These are of same energy and we are calling them sp2 because we know one s orbital and two p orbitals participated in formation of these three hybridized orbitals. So what's the shape is going to be for boron trifluoride? It is basically formed by the overlap of three half-filled sp2 hybrid orbitals. The green in color, the orbital which are green in color are sp2 hybridized orbital, and these orange color orbitals are for fluorine atom. Okay, so we know that the three fluorine atoms are attached with boron atom, making it a trivalent atom. In this way, we can see that sp2 hybrid orbital participate or overlap with the half-filled orbital of fluorine atom to just create a bond. So this is the basically overlap of different orbitals between Sp2 hybridized orbital in case of boron and then one half-filled atomic orbital of fluorine. So the shape is going to be trigonal planar. These three half-filled Sp2 hybrid orbitals are planar and oriented at the angle of 120. Like in this case, we can see that there is no lone pair involved in boron atom. So there will be equivalent repulsion between this bond pair to this bond pair and then this bond to this bond pair and to this bond pair as well. So these are going to be arranged at the maximum distance where the molecule gets the stability, and in this case it is going to be 120. This is the angle. Okay, let us take another example of ethene. This is the very basic molecule in organic chemistry. Same is the case. Let us take the example, the electronic configuration of carbon atom, where we see there are two half-filled orbitals, but in excited state we have this electron jump to this orbital, so making four half-filled orbitals. Okay. Right now these are atomic orbitals basically. So what is going to happen? We see that there are four electrons, but what is going to happen? One S and these two p orbitals participate to give us three Sp2 hybrid orbitals. Okay. So in the formation of ethene, what we observe, each carbon atom is having with one half-filled p orbital perpendicular to the planar Sp2 hybrid orbital, because we observe a pi bond as well in case of ethene. So we know that each carbon atom undergoes Sp2s overlap with two hydrogen atoms, where we can see this one. This is Sp2s orbital because there are two hydrogen atoms attached with each carbon in case of ethene, and then Sp2 overlap between two carbon atoms, because in ethene there are two carbon atoms and these are doubly bonded, out of which one is the sigma bond and the second one is the pi bond. And the partially filled p orbital undergoes sideways overlap to form that pi bond. We are talking about this pi bond. Okay, this is the pi bond, and we know that pi bond is always formed by the result of overlap of two orbitals undergo sideways overlap. Okay. So you can see in this diagram that this is the carbon atom and this is the first Sp2 hybrid orbital, this is the second Sp2 hybrid orbital, and this is the third Sp2 hybridized orbital. And the same is case with the second carbon atom of ethene. This is the first and this is the second. This one is the third Sp2 hybrid orbital. So we know that a hydrogen having only one electron in s orbital, this overlap is going to be Sp2s. Even this one as well, Sp2 S. And same is the case here, Sp2 S overlap and then Sp2. But in this case we observe Sp2 Sp2. Basically this is because of one half-filled atomic orbital p orbital that was left in case of carbon excited state electronic configuration. So this is the hybridization of ethene. In ethene, each carbon atom undergoes Sp2 hybridization to form 3 hybrid orbitals which are coplanar and oriented at the angle of 120 as we discussed in earlier slides. So this is basically as a whole molecule of ethene. Each bond is basically oriented at the angle of 120. Sp2 hybridization occurs when a carbon atom is attached to 3 groups, and these may be 2 hydrogen atoms or some other atoms as well having half-filled orbital. And in all the above examples, we just observed that the carbon was attached to only 2 hydrogen atoms and 1 carbon atom because we were discussing about ethene. So this is the today's lecture. In this lecture, if you are going to face any difficulty, let us know in the comment section. We'll try to answer your questions. See you in the next lecture.